start just by recognizing that the most important challenges that we have ahead of us today are all pretty global in nature. They're also challenges that we have multidisciplinary needs for, and they're pretty complex. So what I want to really get across to everyone with respect to why it's important that we're here is because this is a great forum. And I just want to start by thanking the Department of Energy and ARPA-E for creating the opportunity for so many of us to come together and talk about all the challenges, all the opportunities to create this energy transition, because it's going to take a lot, and I think you'll hear that throughout my talk. It's going to take a lot of us doing new things together in our areas of expertise to make this work. Let me see if we can get some slides up here. Well, the good news is some of the slides that you've already seen earlier today talking about the mission around energy transition and the fact that we have so much of our emissions coming from the energy sector is really the reason why energy is at the heart of solving for climate change. So we have 40% of our energy sector today, 40% of the emissions in the energy sector come from power. But let me back up. Let's just see if we can get these slides up here real quick. I'll give it a moment. Fantastic, thank you. So like I said, we're all here for the right reason. We can't do this transition for a sustainable future without working together. And I say this representing GE, a company that has a third of the world's energy comes from our machines, and we have grid equipment and software in grids around the world. So if we know that we need to do this together, you should take that pretty seriously. This is something that is going to take all of us, and more than just technology, which I'll get to as well. Here's the slide I'll go very quickly through because we've already heard this now. 75% of emissions come from the energy sector. So being able to address climate change isn't just something that we need to do because we're a big part of it, we're the big part of it. So this has to be the focus. We can't get everything else right and not have the energy transition happen, or we won't be able to address climate change at the time frame and the scale that we need. So one thing I want to just highlight for everyone, because there are no shortage of challenges in the world. I want to recognize that up front. And I also appreciate that it's easy to feel overwhelmed by all the sort of bad news every day. That cycle is kind of eating at our psyches. I want to reframe some of these big, unprecedented events in a way that might help us think more about the opportunity that they're providing us. So let's start with the COVID-19 global pandemic. This changed the world more than any of us could have even imagined before 2020. It exposed these really fragile supply chains that we had built up. It highlighted social inequities, not just on the other side of the world, but in our own communities. And it led to this global economic crisis. But what we got out of it is we have these new pathways for communication and collaboration. I think probably everyone in this room is pretty good at virtual meetings now. You can meet and talk to people you never could before. And we saw some really amazing deployment of technology in the last couple of years, namely this life-saving vaccines. Also, governments are looking for a way out of the economic crisis. So now clean energy has been established as a vehicle for growth. That is a great setup for what we need next. All these extreme weather events that are happening around the world, they're putting the climate crisis in sharp focus in a way that, unfortunately, it's impacting too many people, and it's, at least now, after decades of doubt, becoming a little bit more real. The good news, after all of this, is that for the first time in history, climate is one of the top 2 voting issues across Europe. We're seeing the youth movement be successful. We just had a climate election in Australia a few days ago. So the world's changing politically as well. And I think this pressure at COP26 that resulted in even more pledges, finally below a 2 degrees Celsius warming, was one of the big opportunities to see how those government and the pressure from constituents like us is helping. And then lastly, this Russian invasion of Ukraine, besides being a humanitarian crisis, obviously it's also just unprecedented disruption of our energy and geopolitical status quo. But I was shocked at how fast decades of energy policy is completely rewritten, in weeks or even days in some cases, mostly because of how Europe is so dependent, 40% of their gas coming from Russia. So we are now seeing this huge appetite growing for a green transition, and fast, because of energy security. So all of these terrible things that have kind of put us in a mild state of depression over the last couple of years, they're also honing our ability to do really hard things and giving us confidence that we can do more and that we must change course. So I want to just reframe and help us kind of move into the next couple slides here with that in the back of our brains. And whenever you're talking about the work ahead, it's great to have a framework. So I just wanted to use the framework from the International Energy Agency, the IEA, because they put out a World Energy Outlook every year. And last year, they introduced 4 scenarios that I want to use throughout this talk. On the left-hand side of the screen, you can see that this is essentially the trajectories of carbon emissions for each of those scenarios for the next 30 years. And on the right-hand side of the screen, it's the associated temperature rise with those scenarios. First scenario is stated policies. Just as you would imagine, it's what our governments are doing today, and if that continued, that's the trajectory. The second one in yellow is announced pledges. This is, just like it sounds, essentially, if we were to do everything that our governments are pledging that they would do in full, we would be on that trajectory. And you can see I even modified it with the advancements in pledges after the COP26 last fall. These 2 scenarios were not designed for any outcome. They were really to do 2 things. To show us that there's this huge gap between policies and pledges. It's called the implementation gap. And they were also designed to show us that neither of those 2, even the best pledges out there, even the ones that came out of COP26, they're unacceptable. So the next 2 are where it gets interesting. Sustainable development is the dark green curve. That's where this is the one designed to meet the Paris agreements. So keeping us within 1.5 degrees of warming by the end of the century. And the net zero emissions scenario is even more ambitious, gets our energy sector to net zero by 2050, and also 1.5 degrees warming without the overshoot that we see in the sustainable development scenario. So huge framework for us to work from. And these are not forecasts, these are scenarios. So take it with a grain of salt and just know the value of these are getting our hands on some of the levers that are going to drive change. The main thing to remember is we need to get in that green zone, and the longer we delay, the harder it's going to be, the more work we have to do to move forward. So let's dive in, because this really captures a lot of what I want you to take away from this talk. If you boil it down, the energy transition, a lot of it comes into 2 arenas: clean electrification and what that means to the grid. So let me start on the left-hand side here. Our emissions around the energy sector come from a lot of places, and the power gen sector of the energy sector is the biggest at 40%. Only 20% of our electricity is decarbonized today, so we have a lot of room for improvement. That's good news to some degree. But we're not going to be able to decarbonize the energy sector just by focusing on the power sector. We need to take industry, transport, buildings, and electrify them, and then run them on that clean energy. So those 2 levers go hand in hand. We're going to see different solutions around the world, different choices that will be made based on a lot of other things that are different, social, geopolitical, historical. But the one common thing is this move to mass electrification. And that's what's going to drive the energy supply to be very different in the future. And I just kind of have a cartoon showing the bar chart where we have carbon-free energy. About 20% of our energy is carbon-free today. It's going to have to be much higher, and it's going to, or all carbon-free, I guess, is our goal, but clean electrification is going to be the majority of that. Now, there's going to be some portion of our energy sector that we can't electrify. It's really hard to abate. Let me put that aside for now and stay in the electrical zone, because the right-hand side of the graph is where it gets really interesting. What does this mean for the grid? And I've been spending a lot of time here because this is groundbreaking. So we're going to have 3 simultaneous transformations of the grid happening in the next decade to 2 decades. Never before has this happened. The first transformation is all rooted in physics. Today, our systems use synchronous machines to connect to the grid. And in the future, we're going to have more wind and solar, renewable energy, that connects to the grid through power electronics. Now, I'm not saying one is better than the other. Today, our systems, it's a pretty elegant design, actually, that uses the inertia from these turbines to keep the grid stable. But power electronics, they're fast, versatile, really easily programmable. There's no reason why we can't create a stable grid environment with using those physics. It's this transition we've got to get right. We can't have a reliability or an affordability gap because we'll lose the social license we'll lose public acceptance for the energy transition. So we've got to do this transition really carefully. The next transformation is how we operate the grid. So today, we have constant fuel. It's relatively easy to control. And in the future, as we move to renewables, it's variable. It's very predictable. That's a good thing, but it's not controllable. We get what we get. That's going to change how we operate the grid. Another big change in the grid environment is where and how we make electricity. So today, large central power plants make electricity and send it out to the load, usually in one direction. Even utility scale renewable energy plants are smaller than the conventional plants we have today. They're going to be more distributed because they go where the resources are best. And depending on the region they're in and whether they're generating a lot of renewable energy, they might be transmitting power in one direction, or they might be getting power from another region. So these big transmission lines have to be able to manage two-way flow of electricity. And lastly, this one is a big one. This is demand. Today, we have constant and predictable demand. Not a lot of demand growth in the past couple decades. If we electrify industry, transport, buildings, not only are we going to have a huge demand growth, but I mean, EVs, they can move around. They can plug into the grid wherever they want. That operational challenge is not insignificant. So before you start to get nervous about this one, I just want to say we have a lot of tools that we can use to operate the grid differently that didn't exist when we created these operational rules generations ago. We have communications and data and controls that we can employ to make the grid operate a new way. We just have to get different parts of this challenge talking together and working together in ways they never had to before. The last transformation is all about value. So imagine we've had fuels that have been worth going to war for. Now we have literally free fuel coming up with renewables. That's going to change how the market needs to work to do this well. Today, we value energy. We have to be able to put value on flexibility and capacity, or we won't build out the right mix to support our resilient grid needs. So this is going to take more access to capital, smart government investment, and maybe most importantly, really clear policy and regulation. And the last chevron on the bottom isn't really a new transformation, it's just build out. Our grid is overdue for an overhaul. It needs to have modern equipment, it needs to have more interconnections for all this new renewable energy, and frankly, it needs to be able to carry 2 to 3 times more power around, because that's what we're going to demand. So another takeaway for this room is we're going to have to collaborate on new technology to meet this challenge, but it's not going to just be technology. We're going to need new codes and standards that we help write. We're going to need new policies that we help lobby for, and we're going to need new market instruments so that the economics around all of this works. This isn't just a systems problem, this is a system of systems challenge for us all. So thinking about what that means for the power mix. So we've talked about renewable energy writ large, but what does that mean specifically? This is, again, looking at one of the scenarios, actually the least aggressive one that gets us into the right framework, the sustainable development scenario. The far left on the bar chart is the stack of our power generation globally in 2020. So 27 terawatt hours, with coal and gas being the top 2 sources of generation. The sustainable development scenario has that growing as an overall stack, about 25% by the end of this decade, with renewable energies being the wind and solar primarily being the big growth engines. But by 2050, it's more than twice what it was in 2020 as a total stack. And renewable energy is bigger than all of the grid output in 2030. What I don't show here, this is the generation mix. The capacity mix is even higher growth because wind and solar have lower capacity factors, so you need more of them, more plants, to get the same output. I also don't show the net zero emissions, but that would be off the page because that's even more renewables, even faster. All of these also have to be connected to the grid, and the interesting thing about all of those scenarios, as I put my grid hat on a bit more, is that they all just assume that we're going to solve the grid constraints, which, as I hope I mentioned and got across earlier, they're not insignificant. So this is another big part of the challenge. There will be some people who say, sorry, can't be done, too much growth, too fast, and I get it. Exponential change is really hard for us to wrap our minds around because it's not what we're used to. So I wanted to show some examples here, really good examples and exciting work that really highlight where forecasting doesn't exactly jive well with these exponential trends. On the left side of the page, you'll see this is a graph of the actual installed solar capacity every year for the last 20 years, and overlaid on it is each year, starting in 2002, of the IEA expert forecast. And you'll see that every year they expected and forecast that we would have about the same amount of solar that was installed that year going forward. Even after many years of seeing exponential increase, they still had good data, data-backed, solid reasoning as to why that just couldn't continue. But it did. It did continue. And I want to show that it can happen the other way too. On the right side of the graph, you'll see that there's the EIA here in the US was looking at coal generation and said, even though it started to trend down in 2008, they would have expected that it went flat to even maybe rebounding and going back up. But every year we saw, with some blips, it continued to go down, really driven by low-cost gas and coal to gas switching. So again, I'm not so concerned about scale. We have to scale sustainably, but I'm not worried about finding the scale. It's the integration that I think is our biggest challenge, the system of systems. And just to pull it all together for one big example of how this plays out, I wanted to show wind. What's going on in the wind industry right now that takes all of these into consideration? So the challenge for the wind industry is that they need to scale essentially 4x this decade. So from about 100 gigawatts to almost 400 gigawatts by the end of the decade. They also need to take the least, I guess the hardest to recycle component today is the blade. It's got to be fully recyclable, and they're going to be competing for critical materials with a lot of other high growth industries. So this is not an easy challenge. Let's look back on what the industry has been doing. For the past 20 years or so, they've been driving down cost through scale. Bigger turbines, more turbines. And this is an example I pulled from our GE product team of 6 different product variations ranging from 2004 to 2019 that show in that time frame, GE was able to make turbines that gave off 4 times more power at 70% less cost. This was a great playbook. And many people will say, wind is mature, it's already the cheapest form of electricity on the planet, we're done, good job. This is just the end of this chapter, because what got us here can't get us there. The next growth, which I described, is going to require a whole new mindset around innovation for wind. It's going to require us to think differently. In fact, the GE approach is we're going to try to industrialize everything about wind. We're going to have to make components differently so that they're sustainable and that they essentially have ensuring quality throughout the life of their system. They're going to be recyclable components, more serviceability, and maybe most important, they've got to be really easy to connect to the grid. So this is a challenge that wind is facing, not in spite of, but because of this big growth. So when we talk about the energy transition, it's actually spurring a lot of great technical innovation and opportunity for all of us. So I'll just wrap it up here, because I know I talked about a lot of different things, so I wanted to capture what I think are the big problems worth solving when it comes to the energy transition. So hopefully I made it clear that the electric power grid is the root of a lot of this change. We need to be able to put it into a position where it's the leading player in the energy sector. Right now it's not the top thing, that we get most of our energy from fuels. To do that, we're also going to have all the new power generation, wind, solar, all those carbon-free power and batteries, energy storage, and all the technologies that are going to come later. They have to be sustainable as we scale them. They need to be able to contribute to the circular economy and be more local, more just. The third thing I haven't mentioned yet, but I can't go without saying, cybersecurity. We're having more distributed, more digital solutions. That's more opportunities for vulnerabilities. Now, if there's something we learned in the last few months, is that energy security is national security. So we need much more resilient systems. We need new products that are designed from the ground up with security by design. And that's going to be a part of our energy transition too. The next 2 that are with the blue background, I just couldn't go without commenting on them, because even though clean electrification will take up 80% of our emissions challenge, we're going to have parts that, as I said before, can't be electrified, very hard to decarbonize, and they're going to need clean fuel. Green hydrogen, green ammonia, all great pathways. And then lastly, it's taken us a long time to address emissions, so much so that we can't do this without also doing a lot of carbon management in a lot of different ways. And then lastly, I'll say it again, it's not just technology. We need legislators and regulators to really have a holistic mindset and approach this policy-based planning and give us a clear path forward. We can't just do this with technology. So the one thing I think about when I have a lot of confidence that we're going to be able to do this, and I've seen really excellent work in probably every one of these spaces. The challenge is doing it together, and when we do it together, we're going to create not just a more sustainable, but a more prosperous world. Thank you.